Have you ever wanted to know how buffer overflow works in the heap segment, but you never understood it entirely? In this video tutorial, I will explain it to you. First, I will talk about the data structure, and then I will compare it to an overrun in the stack segment. And last, but not least, I will exploit my own demo code and explain what happens in the memory. Stay tuned.
Let's talk about the data structure and how variables are processed in the memory. Local variables are generally stored in the stack. Dynamic variables are written into the heap area. The stack is filled into the direction of the heap. Written strings are growing the other direction. The heap is filled into the direction of the stack, and strings written to the heap are growing in the same direction. When a dynamic variable is written into the heap, there is also a pointer to the variable stored in the stack, which points to the address in the heap. Let's have a look how buffer overflow works in the heap compared to an overrun in the stack. The stack is filled into the direction of the low memory, while strings grow in the other direction. In this way, the variables are placed near the return address, which allows you to overwrite the address of the code which should be executed next. If you want to learn more about buffer overflow in the stack area, make sure to check out my buffer overflow video tutorial. In the heap segment, the variables are written into the direction of the high memory. Written strings grow in the same direction. With an overrun in the heap area, you can't overwrite critical addresses like the return address that easily as in the stack. To exploit the heap, you have to know how the program reacts while running, either by knowing the source code or by testing, which is quite an effort. That's why exploiting the stack is more common. I've prepared a little program to demonstrate how to exploit the heap. Don't use it, it's very bad code. In the main function, I reserve dynamic memory for the variables text and command. I will copy a string into the command variable, which creates a log entry and will be executed later. But I made a huge mistake. I did not check or limit the user's input. If I run my program and insert the right number of characters, nothing bad happens and my text is written to the log file. For a better understanding, you can see the values. But what if I don't insert 4 characters only? Let's have a look at the current system users. As you can see, there is only one user yet. I will pass my exploit as a shell variable and call my function with the exploit parameter. A buffer overflow is triggered and the program stops working, but the damage is already done. You can see that the value of the command variable changed and another command was executed. Let's check the uses. This exploit created the new user backdoor, which was already added to the local administrator group. So what happened in the memory? When I initialized the variable text, the pointer of the variable is written to the stack. It contains the address of the variable in the heap. The second variable, command, is initialized in the same way. In the heap, it is placed near the first variable. In the same direction, written strings are growing. Because there is no limit to the user's input, I'm able to override the second variable if I insert a string which is long enough. The value of the variable command gets changed and the command is executed before the program crashes due to a buffer overflow.
If you want to avoid buffer overflows, make sure that you always check the user's input and use safe libraries. If you like this video tutorial, give me a thumbs up and subscribe to my channel. Leave me a comment to tell me what you like best or what I should improve in the next video. Or is there any IT security topic you want me to talk about? Thank you for watching and see you in the next video.